Hi students, a woman can swim 8 km per hour in still water. If the speed of the stream is 4 km per hour, then find the time taken by the woman to cover the distance of 16 km upstream. So in this problem, the data given to us are speed of the swimmer in still water. It is going to be 8 km per hour. And the speed of the stream is given to be 4 km per hour. And we are going to find the time taken by the woman to cover the distance of 16 km. So distance is also given to us. Distance is given to be 16 km per hour. 16 km. Okay. And she is going to swim upstream. She is going to swim upstream. Okay. Upstream means she is going to swim against the flow of the water. Upstream. Here, the stream of the water upstream, flow of the stream is going to be 4 km per hour. Okay, it is going to be in this direction. The swimmer is going to swim in the opposite direction, and she is going to swim with the speed of 8 km per hour. Now, the time taken, so speed of the swimmer with upstream, in upstream, it is taken as V, that is equal to 8 minus 4, that is equal to 4 km. We subtract the speed of the stream because she is going to swim against the flow of the water. So our speed reduces. How much it reduced? 4 km per hour. Now time is given by the formula. Time taken is given by distance divided by speed. And distance covered is 16 km, and time taken is, speed of the swimmer is 4 km. So we divide 16 by 4. So the answer is 4 hours. So she takes 4 hours to cover the distance of 16 km upstream. A man can swim upstream at 6 km per hour and downstream at 10 km per hour. Find the speed of the stream and speed of the man in still water. Here, the speed of the man in upstream as well as the downstream are given to us. With the given data, we are supposed to find the stream of the water, speed of the water and the speed of the man in still water. Okay. We assume speed of the man in still water. Because it is the speed, it is taken as x km per hour. We take speed of the stream is equal to y km per hour. Okay. Now, speed of man to swim upstream. What happens in upstream? Upstream is swimming against the flow of the water, so the speed gets reduced. So we take v is equal to x minus y, and it is given to us, upstream is given to us as 6 km per hour. Speed of man to swim downstream, we take this as u, and it is given by the value x plus y. Downstream, when he swims along the flow of the water, he is going to swim, so he is having extra support of the flow of the water, so the velocity speed is added, x plus y, and x plus y is given to be 10 km per hour. We can see that in upstream the speed is reduced, downstream the speed increases. We solve this equation. X plus y is equal to 10, x minus y is equal to 6. We simplify. 2x is equal to 16. So x is equal to 16 divided by 2, that is equal to 8 km per hour. Substitute this value in any one of the equation. We substitute x plus y is equal to 10. 8 plus y is equal to 10. When you substitute, x is equal to 8. So y is equal to 10 minus 8. That is equal to 2 km per hour. So we found out the values what we require. So speed of man in still water is 8 km per hour. Speed of the stream is 2 km per hour. In 2 hours, a boat covers a certain distance in a river downstream at 17 km per hour and returns back at 9 km per hour. Find the speed of this stream. Okay. Now we take speed of the boat. We take speed of the boat in still water. X km per hour. Speed of stream y km per hour. Here we are going to find only the speed of the stream. So it's enough if we find the value for y. Now they have given two data now. Speed downstream is 17 km per hour and upstream, return back means upstream, it is going to be 9 km per hour speed. So we take speed of the boat downstream. When it goes downstream, the speed increases. So we take x plus y is equal to 17 km per hour. Upstream, when the boat goes upstream, the speed reduces. So we take x minus y, that is given to be 9 km per hour. And we are going to concentrate only on the speed of the stream. So we take the equation. X plus y is equal to 17. X minus y is equal to 9. We subtract. Sign change. So y plus y is 2y. Here the term getting cancelled. 17 minus 9 is going to be 8. So y is equal to 8 by 2, which is nothing but 4 kilometers per hour. So we conclude. So speed of the stream is 4 kilometers per hour. A boat goes 20 kilometers upstream and 30 kilometers downstream in 5 hours each time. So every time it takes 5 hours. When it goes upstream, it takes more time. Okay, so distance is very less. Only 20 kilometers is going to cover in 5 hours. When it is going downstream, it covers a distance of 30 kilometers per hour. In such a situation, we are supposed to find the speed of the boat in still water and the speed of the current. So speed of the flow of the water, we are going to find out. So as usual, we take let the speed of the boat in still water x kilometer per hour, speed of the stream, that is current, we take it as y kilometer per hour. We are supposed to find the value for x and y. Now, for upstream, we are doing the calculation. Upstream, speed of the boat will be taken as x minus y, and time is going to be 5 hours, and distance covered is 20 kilometers. Now distance is given by the formula speed into time. So we get 20 is equal to x minus y into 5. So we have an equation now. 5x minus 5y equal to 20. For downstream, we are going to do the calculation. Downstream, the boat is going to sail along the stream of the water. It is going to go along the water. So the speed of the boat downstream will be x plus y, and the time taken is again 5 hours. Distance covered during downstream, it is given to be 30 kilometers. Again we have the formula. Distance is equal to speed into time. So here 30 is equal to speed is x plus y into time, 5 hours. So we have another equation. 5x plus 5y is equal to 30. Now we have to solve these two equations. So the equations are 5x minus 5y is equal to 20. Here it is 5x plus 5y is equal to 30. So we divide this equation by 5. So we get x minus y is equal to 20. And we divide this equation with 5 again. So we get x plus y is equal to so we have two equations here. The first equation is five x minus 5y equal to 20. We divide this equation with the 5, so we get x minus y is equal to 4. This equation 5x plus 5y equal to 30. Again I divide this equation by 5. We get x plus y is equal to, we divide 30 by 5, so you get 6. So we solve this one. X plus y is equal to 6. We add. So when we add, y minus 1 plus y getting cancelled, x plus x is 2x. So 2x is equal to 10. So x is equal to 10 divided by 2. That is equal to 5 km per hour. And substitute x is equal to 5 in this equation. X plus y is equal to 6. So 5 plus y is equal to 6. Y is equal to 6 minus 5. That is equal to 1 km per hour. So we got the answer now. So conclusion. Speed of boat in still water. Five km per hour. Speed of the current. It is given to be 1 km per hour. This is the final answer. We can solve this problem in another method. Alternate method. A boat goes 20 km upstream and 30 km downstream in 5 hours each time. Find the speed of the boat in still water and the speed of the current. Okay. So in the upstream, in 5 hours it covers the distance of 20 km, and in downstream, and in the same time of 5 hours it is going to cover 30 km. In upstream it is going to sail against the flow of the water. So the speed will be x minus 5 for upstream. Okay, and it will be taken as v. And for the downstream, it is going to sail along the flow of the stream. So the speed of the boat will be x and the flow of stream will be y. For downstream it will be x plus y and it will be taken as u. So now we write the data is given to us. For upstream, distance covered is going to be 5 km. Distance covered is, for upstream it is going to be 20 km, and time taken for this travel is going to be 5 hours. So we try to find the speed for upstream. Speed of the boat in upstream. We are having the formula to find the speed. It is distance covered by time taken. So we substitute. When we substitute, it is going to be 20 divided by 5, which is nothing but 4 km per hour. So this is your speed of the boat in upstream. Upstream speed we denote it by V, and it is nothing but x minus y usually. For downstream, we calculate for downstream now. For downstream, distance covered is given to be 30 kilometer, and time taken is same 5 hour. Now speed of the boat downstream. Again it is going to have the same formula, distance divided by time. So downstream speed is taken as u. So u is equal to x plus y, that is equal to distance traveled is 30 and time is going to be 5. So we cancel the term. So u is equal to x plus y, that is equal to 6. So we have two equations now. X plus y is equal to 6, x minus y is equal to 4. We cancel the term. So 2x is equal to 10, which means x is equal to 10 divided by 2, that is equal to 5 kilometer per hour. Substitute x value is equal to 5. So we get 5 plus y is equal to 6. Y is equal to 6 minus 5, that is equal to 1 kilometer per hour. So speed of the boat in still water is 5 kilometer per hour. Speed of the current is 1 kilometer per hour. Here we are having a problem. The ratio of speed of a motor boat in still water and that of current of water is 25:4. The motor boat goes certain distance downstream in 5 hours 15 minutes. How much time will it take to come back? So in this thing, we are going to take the speed of the motor and here we are going to take the ratio of the speed of the motor boat in still water and the current of water is 25:4. It is given in the ratio. Okay, and the motor boat goes certain distance and it goes in downstream. Time taken is going to be 5 hours 15 minutes. So we are supposed to find how much time will it take to come back. So flow of water, flow of the stream is given, will be taken as y. Speed of the water boat. Here we are having an interesting problem. The ratio of speed of a motor boat in still water and that of current of water is 25:4. The motor boat goes certain distance downstream in 5 hours 15 minutes. We are supposed to find the time taken for the motor boat to return back. So we are not given with the speed of the motor boat in still water as well as the speed of the current of the water. They are given, the speed are given only in the ratio. We take speed of the motorboat in still water. X kilometer per hour. Speed of the current of water we take as y kilometer per hour. Given x is to y is equal to 25 is to 4, which implies x divided by y is equal to 25 by 4. We cannot take as such 25 and 4 for x and y. We take some multipliers, 25t by 4t. So we take x to be equal to 25t kilometer per hour and speed of the current of water taken as 4t kilometer per hour. Now the motorboat goes downstream. Downstream speed of the motorboat will be equal to x plus y. So we have taken x is equal to 25t and y is to be equal to 4t. So which is nothing but 25t plus 4t, that is nothing but 29t. Now time taken for to cover the distance given to us, it is equal to 5 hour 15 minutes. We convert everything to hour, it is 5 1 by 4th of an hour, because 15 minutes is nothing but 15 divided by 60. Convert this minutes to hour, it is 1 by 4. So 5 1 by 4 hour. When you simplify this one, it is 21 by 4 hours. So distance covered during this time, distance covered by the motorboat will be equal to speed into time. Speed is 29t and the time is 21 by 4. Now let us calculate for the downstream. Let us calculate for the upstream. So upstream, it is going to travel the same distance. So distance covered will be equal to 29 into 21 by 4t. Now the speed, because it is upstream, it is going to be x minus y, that is nothing but 25t minus 4t, that is equal to 21t. Now we are going to find the time. Time is nothing but time is equal to distance by speed. So we have 29 into 21 by 4t divided by 21t. T cancels, 21 cancel, so it is 29 by 4. So 29 we divide by 4, 7 4s are 28, balance 1. So it is 7 1 by 4 hours, which is nothing but 7 hours 15 minutes. Here we are having another interesting problem. A boat goes 20 km upstream and 22 km downstream in 6 hours. In 6 hours, the boat covers 20 km upstream and 22 km downstream. Also, it goes 25 km upstream and 33 km downstream in 8 hours. We are supposed to find the speed of the boat in still water and that of the stream. Here we are having another interesting problem. A boat goes 20 km upstream and 22 km downstream in 6 hours. Again, it goes 25 km upstream and 33 km downstream, but this time it takes 8 hours. Find the speed of the boat in still water, and we are supposed to find the speed of the stream also. So we are having speed of the boat, we are going to take it as x, and the flow of stream is taken as y. It is upstream. When the boat goes against the flow of water, then the speed getting reduced. So speed of the boat in upstream will be x minus y. And here the speed of the boat is x, flow of the stream is going to be y km per hour, and in downstream the boat is going to flow along the flow of the water. So the speed increases. The speed of the boat in downstream will be x plus y. Okay. Now we are having two cases. We write. We take speed of the boat in still water. X km per hour. Speed of the stream, that is speed of the flow of the water, we take y km per hour. Okay. Now we are supposed to find the values for x and y with the given data. We write the speed of the boat upstream. Upstream is v, that is equal to x minus y. Speed of the boat downstream, u, that is equal to x plus y. Now the boat goes in two conditions. One is it goes 20 km upstream and 22 km downstream in 6 hours. So we are having the formula. Time taken is nothing but distance by speed. So we take 20 divided by 20 km upstream. So upstream speed is x minus y. 20 divided by x minus y plus downstream, it is 22 km. 22 km it is going to travel downstream. 22 km divided by x plus y, and it is going to be 6. And next case, 25 km upstream. So 25 divided by x minus y plus 33 divided by x plus y is equal to 8. We are supposed to find the value for x minus y and x plus y, Already we have taken x minus y and x plus y as v and u respectively, but they will appear in the denominator. So when you solve the expression, it will be tedious. So we try to take, we substitute 1 by x minus y is equal to a and 1 by x plus y is equal to b. We try to simplify this expression by this substitution. So this equation turns out to be 20a plus 22b is equal to 6, and here it is 25a plus 33b is equal to 8. We have to solve this equation. We take the first equation, 20a plus 22b as first equation and 25a plus 33b as second equation. Okay, here we are having 20 and 25. Try to cancel the term containing a. So I take LCM for 20 and 25. It turns out to be 100. So I multiply first equation with the 5. So what happens? 100a plus 110b is equal to 5 into 6, 30. And I multiply second equation with the 4. 4 into 25, 100a, 4 into 33, 132b is equal to 4 8s are 32, and we simplify this expression minus minus minus. So we try to get the value for b here. So this is a term is getting cancelled. So minus 22b is equal to minus 2, which implies b is equal to minus 2 divided by minus 22. That is nothing but 1 by 11. Substitute b value is equal to 1 by 11 in the first equation. Your first equation is 20a plus 22b is equal to 6. 20a plus 22 into 1 by 11 actually is equal to 6. We cancel the term. 11 goes in 22 2 times. So 20a is equal to 6 minus 2. 6 minus 2 is 4. So a is equal to 4 divided by 20. That is equal to 1 by 5. Now we are having the expression (1 by x minus y is equal to a), that is equal to 1 by 5, which implies x minus y is equal to 5. Again 1 by x plus y is equal to b, that is equal to 1 by 11. So x plus y is equal to 11. So we have two equations now. Again another set of linear equation. X plus y is equal to 11 and x minus y is equal to 5. So we cancel. 2x is equal to 16. So x is equal to 16 by 2, that is equal to 8 km per hour. Substitute x is equal to 8 in x plus y is equal to 11. So 8 plus y is equal to 11. So y is equal to 11 minus 8. The answer is 3. So speed of the boat in still water is 8 km per hour and speed of the stream is 3 km per hour. A boat covers 4 km against the stream in 1 hour and covers the same distance in the direction of the stream in 40 minutes. How long will it take to go 10 km in still water? So they have given very clearly the boat covers 4 km. So it is going to cover 4 km upstream as well as downstream. Okay. And it takes 1 hour for upstream and it takes only 40 minutes to cover the downstream. So we take the speed of the boat in still water as x, flow of the stream as y. For the upstream, v will be equal to x minus y. For the downstream, same thing, speed of the boat is x, flow of water, flow of the speed of the stream is going to be y. Because it is downstream, the speed is going to be increased. So u is equal to x plus y. And it is going to cover a distance of 4 km in 1 hour. With the given data, we are supposed to find the speed of the boat in still water. That is, we are supposed to find the value for x. Then we can find the time taken for the boat to cover 10 km in still water. So we write, let the speed of the boat in still water be x km per hour. Speed of the stream, that is speed of the flow of the water, we take it as y km per hour. Okay. Now we are supposed to find the speed of the upstream and the speed of the downstream. To find the value, they are given the time and the distance covered. We write for upstream distance covered for the upstream 4 km and the time taken to cover this distance given to be 1 hour. So upstream speed of the boat, how to calculate upstream speed of the boat? Speed is nothing but distance covered by time, which is nothing but 4 divided by 1. That is 4 km per hour. So v is equal to x minus y. For downstream, it is going to cover the same distance. But the time taken is going to be only 40 minutes. So we try to convert into hour. So 40 divided by 60, which is nothing but 2/3 of the hour. Now speed of the boat downstream, or downstream speed of boat is distance by time. Four divided by 2 by 3, so 12 by 2, that is nothing but 6 km per hour. So we are having x plus y is equal to 6 downstream speed, upstream speed x minus y is equal to 4. We try to solve this two linear equation in x and y. We cancel this one. So 2x is equal to 10. So x is equal to 5 kilometer per hour. So we got the speed of the boat in still water. Kilometer per hour. Now we are supposed to find the time taken for the boat to cover a distance of 10 kilometer in still water. Okay. So time taken by the boat to cover 10 kilometer in still water is nothing but distance by speed in still water. It is given to be 10 divided by 5. That is nothing but 2 hours. So this is the answer. In this problem, a man takes twice as long as to row a distance against the stream as to row the same distance in the direction of the stream. Find the ratio of speed of man in still water to the speed of the stream. So in this problem, they are given he takes twice as long as the to row a distance against the stream. So it takes to travel against the stream 2 times the time taken to row along the stream. So we take the speed of the boat as x and flow of stream speed to be equal to y kilometer per hour. So it travels against the stream, so his speed reduces. So we take it as x minus y against the stream. Down the stream, along the stream, same thing. The speed of the boat is x kilometer per hour. Flow of the stream is y kilometer per hour. Because he is going to sail along the stream, we are going to take this as x plus y. So we take let the speed of the boat, here it is given, is going to row. Okay. Speed of rowing the boat in still water, we take it as x kilometer per hour. Speed of the stream, we take it as y kilometer per hour. And the question is, we are going to find the ratio of the speed of man rowing the boat in still water to the speed of the stream. That is, we are supposed to find the ratio of x is to y. This is what we are supposed to find. And we are going to take distance. It is not given, so we take it as d kilometer. So calculation for the upstream. Speed in still water, x. Speed of the stream, y kilometer per hour. So upstream speed is taken as v is equal to x minus y. So we know usual formula, speed is equal to distance by time. And from this formula we are going to take time, t1 is equal to distance we don't know, so we take it as d already assumed divided by speed, which is nothing but x minus y. And for downstream, same calculation we are going to do it for downstream. Speed in still water x, speed of the stream is y, because he is going to row along the flow of the water, downstream speed it is going to getting added x plus y. So time t2 is equal to distance divided by speed, which is nothing but d divided by x plus y. Now the data given to us is it takes twice as long as to row the same distance against the stream as to row the same distance in the direction. Because in the upstream the time will be taken more, and the data given to us is t1 is twice the t2. t1 is time taken to row against the flow of the water, and t1 is the time taken to cover the same distance along the water. When you travel along the water, the time will be very less because the speed is more. So according to the data, t1 is equal to 2t2. So we substitute d divided by x minus y is equal to 2 into t2, d divided by x plus y, and we can see the ratio here. We can cancel d on both sides, so we get x plus y is equal to 2 into x minus y. So we have the expression x plus y is equal to 2x minus 2y. We take like terms together, so we get x minus 2x is equal to minus 2y minus y. So minus x is equal to minus 3y. So minus we cancel on both the side. So x by y is equal to, it is 3, because we are going to write this as ratio, we write the denominator as 1. So we get the answer x is to y is equal to 3 is to 1. That is speed of man in still water to speed of the stream is equal to 3:1. So this is the final answer. Here we are having a problem. A boat takes thrice as long as to go upstream to a point as to return downstream to the starting point. If the speed of the stream is 5 km per hour, find the speed of the boat in still water. We have already seen one problem in which we found the ratio of the speed of the boat in still water to that of speed of the stream. In this problem, the speed of the stream is given to us. With the help of that, we are supposed to find the speed of the boat in the still water. So as usual, we used to assume that the flow of the stream, the speed of the flow of the stream is y km per hour. Speed of the boat in still water will be taken as x, and for the upstream, speed of the boat will be reduced because it is going to travel against the flow of the water. So the speed will be taken as x minus y. Now for the downstream concept, the speed of the boat will be x as usual, and the flow of the water, speed of the stream will be y km per hour, and speed of the boat downstream, it is going to go along the flow of the water. So speed increases. So the speed will be taken as x plus y. And here it is given to us the time taken for the upstream is 3 times the time taken for the downstream travel, keeping the distance traveled same. So we take speed of the boat in still water x km per hour, speed of the stream taken as y km per hour. For upstream, speed of the boat upstream x minus y, speed of the boat downstream speed of the boat upstream, the speed is reduced, so it is x minus y km per hour. And speed of the boat downstream is equal to x plus y km per hour. Now we have the relation between the distance, speed and time taken. So distance covered is equal to speed into time. Okay. Now from this we get time taken for the upstream or downstream will be given by distance by speed. Okay. Now, because the distance is not given to us, we take the distance to be some constant. So distance is taken as d kilometer. Okay. Now time taken for upstream travel is equal to d divided by distance by speed. Speed for upstream travel is x minus y. Time taken for downstream travel, that is d is divided by x plus y. And they have given two data now. One is the time taken for the upward travel is 3 times the time taken for the downward. And next one is flow of this stream. So given T1 is equal to 3 times T2. So for upstream travel we take time to be T1, and for downstream travel we take the time to be equal to T2. So we substitute all the values. So d divided by x minus speed of the stream will be 5. So we can take y is equal to 5 is equal to 3 times d divided by x plus 5, and we can cancel d on either side and we cross multiply, we get x plus 5 is equal to 3 times x minus 5. So x plus 5 is equal to, we multiply 3 on the other side, so it is 3x minus 3 into 5, 15. So we bring x term to the left side and constant term to the other side. So we get x minus 3x is equal to minus 15 minus 5. So we simplify this expression, x minus 3x is minus 2x, this is minus 20. So we cancel minus on both sides. So x is equal to 20 divided by 2, which is nothing but 10. So speed of the boat in still water is 10 kilometer per hour. So this is the answer. A boat moving upstream takes 6 hours 36 minutes to cover a certain distance, while it takes 3 hours to cover the same distance downstream. So for the upstream travel it takes 6 hours 36 minutes. For downstream it takes only 3 hours. We are supposed to find the ratio of the speed of the boat in still water to the speed of the stream. So we take speed of the boat to be equal to x and the flow of the stream as y, kilometer per hour, everything in kilometer per hour because it is going to be speed. So for the upstream the speed will be x minus y. Here for the downstream the speed of the boat is x kilometer per hour, flow of the water will be y kilometer per hour, and because it is going to be traveling along the flow of the water it will be x plus y. Let the speed of the boat in still water x kilometer per hour speed of the stream taken to be y kilometer per hour. So speed of the boat for upstream travel is x minus y. Speed of the boat for downstream is taken as x plus y kilometer per hour. Now, for the upstream travel, time taken for upstream travel (6 hours 36 minutes). 6 hours 36 minutes. We have to convert everything to hour. So we try to convert 36 minutes to hour. So we divide 36 by 60. So it is nothing but 3 12s are 36, 5 12s are 60. So this is 6, 3 by 5th of an hour. When you simplify, this will be in improper fraction 33 by 5 hour. Multiply 5 with the 6, 30, 30 plus 3, 33 by 5 hour. And time taken for downstream travel it is given to be 3 hours. And we very well know that distance traveled is nothing but speed into time, or in other words, it can be written as time into speed. So distance traveled for upstream is equal to distance traveled downstream. We substitute using the formula. It is time into speed. For the upstream, the time taken is going to be 33 by 5 multiplied with upstream speed x minus y, which is equal to distance traveled for downstream. Okay, how to calculate? Again the same formula, it is speed into time. It is going to be time for the downstream travel is 3 hours, and we are going to multiply it with the speed for the downstream, which is nothing but x plus y. So we take 33 into x minus y is equal to, we cross multiply this 5, 15 into x plus y. We multiply and simplify, we get 33x minus 33y is equal to 15x plus 15y. We bring all the terms together, like terms together, that is 33x minus 15x is equal to 15y plus 33y. We bring that minus 33y to the right side. So we simplify this expression, 33x minus 15x, 33 minus 15, because x is going to be common. So 33 minus 15 is 18x. Is equal to 15y plus 33y. When you add, it is going to be 48y. So from here, we are going to get x by y is equal to 48 divided by 18. So 6 is the common factor. So we divide this one by 6. So 8 in the numerator and 3 in the denominator. So the ratio of the speed of the boat in still water to the speed of the stream is 8:3. So speed of boat in still water is to speed of stream is given to be 8:3. So this is the final answer. So this is how we have to find the solution for this problem. A motorboat takes Hi students, a motorboat takes 3 hours to cover a certain distance upstream and return back the same distance downstream in 1 hour 15 minutes. If the speed of the stream is 7 km per hour, find the speed of the boat in still water. So here the time taken for the upstream travel and the time taken for the downstream travel are given to us, and the speed of the stream is also given to us. We are supposed to find the speed of the boat in still water. So we take the speed of the boat in still water to be x km per hour, speed of the stream to be y km per hour. So speed of the upstream, the boat travels against the flow of the water, so its speed reduces. So it is x minus y. And here the speed of the boat is taken to be x km, same as for upstream, and the flow of the stream is y km per hour, and for downstream it is going to travel along the flow of the water, so boat travels a little bit faster and the speed is given to be x plus y. All the values are in km per hour. For the upstream travel it takes 3 hours, for the downstream travel it takes 1 hour 15 minutes. So with the help of the speed and the time taken for the upward travel as well as downward travel, we can find the distance traveled by the boat. And here it is given the upward travel distance is same to the downstream travel. So with this data we are going to start solving the problem. Speed of the boat in still water. X km per hour. Speed of the stream. Y km per hour. Speed of the boat upstream. Speed of the stream, it is y km per hour, and we take and y value is given to us. Speed of the stream, it is going to be 7 km per hour. It is given to us. Now speed of the boat upstream. It is for upstream it is x minus y km per hour. Speed of the boat downstream. Which is nothing but x plus y km per hour. And y value is given to us, so we substitute. It is nothing but x minus 5 over here, and here it is x plus 5. Now Time taken for upstream travel. Time taken for upstream travel. It is given to be 3 hours. And time taken for downstream travel. One hour 15 minutes. This 15 minutes should be converted to hour. So we divide 15 by 60. So it is 115. This is 4 15s are 60. So now 1 hour 15 minutes we have to convert to hour totally. So 1 by 4. We simplify this expression, it is going to be 4 ones are 4, 4 plus 1 5. So 5 by 4 hour. And we are going to use another formula. Distance is equal to time into speed or speed into time. Because the distance traveled for the upstream travel as well as the distance traveled for the downstream travel are same, we equate both of them. Distance upward travel is equal to distance traveled for downstream. So we substitute. Distance is nothing but time into speed. So for upstream, the time taken is going to be 3 hours. So it is 3 into speed for upstream, x minus 5, which is equal to, for downstream, the time taken is going to be 5 by 4 of hour, 5 by 4 hours. And it is going to be multiplied with the speed. For downstream, it is x plus 5. So we cross multiply now. So 4 into 3. So this 4 is multiplied here. 4 3s are 12. 12 into x minus 5 is equal to 5 into x plus 5. So we simplify. 12x minus 12 into 5 is 60 is equal to 5 into x, 5x, 5 5s are 25. So we bring the term, x term to the left hand side and minus 60 to the right side. So it is 12x minus 5x is equal to 25 plus 60, which implies 12x minus 5x, it is 7x. 60 plus 25 is 85. So we try to get the value for x. X is equal to 85 divided by 7. We bring the 7 to the right side. So 85 divided by 7 is equal to 15 kilometer per hour. So we found the value for the speed of the boat in still water. So speed of the boat in still water is 15 kilometer per hour. Here we are having a typical question. A boat rows a distance of 12 kilometer downstream at 13 kilometer per hour and covers the same distance upstream at 7 kilometer per hour. Find the average speed of the boat. So here the distance traveled is given to us. It is 12 kilometer in both the direction, upward as well as downward. Downstream speed given to us. Downstream speed is 13 kilometer per hour and upstream speed also given to us. It is going to be 7 kilometer per hour. find the average speed of the boat. So we try to solve this problem. We take speed of the boat in still water x kilometer per hour and speed of the stream is given to be, we take it as y kilometer per hour. Okay. And actually the average speed doesn't depend on the distance covered. Okay. Now we take speed of the boat upstream. Upstream speed, it is actually x minus y, because it is going to travel against the flow of water, the speed reduces, so it is x minus y, and x minus y value is given to us, which is nothing but 13 kilometer per hour. Speed of the boat downstream. Because it is going to sail along the flow of the water, the speed increases, so it is x plus y, which is nothing but 7 kilometer per hour. So with the help of this expressions, we are supposed to find the value for x and y, because average speed of the boat is given by the formula x minus y into x plus y divided by x. I told you already, the average speed of the boat doesn't depend on the distance covered. It is going to depend only on the upstream speed, downstream speed, and speed of the boat in still water. So we are supposed to substitute for this value x. So for that we have to solve this equation. So we try to solve. X minus y is equal to 13, x plus y is equal to 7. We simplify this expression, 2x is equal to 20. So x is equal to 10. So we substitute here, x minus y is 13, x plus y is, Hi students, we are having a problem here. Hi students, we are having a typical problem here. A boat rows a distance of 12 km downstream at 13 km per hour and covers the same distance upstream at 7 km per hour. And we are supposed to find the average speed of the boat. We are supposed to find the average speed of the boat. So it is going to travel 12 kilometers upstream and it is going to cover the same 12 kilometer downstream, but the upstream speed is 7 kilometer and the downstream speed is 13 kilometer. Okay, and for this problem we are going to use a formula. Okay, average speed of the boat is nothing but x plus y into x minus y divided by x. We are going to use this formula to find the average speed of the boat. Okay, so we start. Speed of the boat in still water x kilometer per hour speed of the stream y kilometer per hour speed of the boat upstream, because the boat is going to travel against the flow of the water, the speed of the boat reduces, so it is taken as x minus y. And for upstream travel, the speed is given to be 7 kilometer per hour. So speed of the boat downstream speed is x plus y, and x plus y is given to be 13 kilometer per hour. So for substituting in the formula, we have the value for x plus y and x minus y, but we don't have the value for x. So we have to find the value for x. How to find the value for x? We have to solve this two equation. So we solve the equation. X plus y is equal to 13. X minus y is equal to 7. So we add 2x is equal to 20. So x is equal to 20 divided by 2, which is nothing but 10 kilometer per hour. So the values which are required to substitute in the formula are derived. So we are going to find the average speed of the boat. So average speed of the boat we substitute x plus y is 13 into x minus y 7 divided by 10. So 7 into 13 91 divided by 10, which is nothing but 9.1 kilometer per hour. So this is the answer. So this problem we are solving it using the formula. The formula to find the average speed of the boat is x plus y into x minus y divided by x. In this problem, a man can row at 8 km per hour in still water. The speed of the current is also given, it is 2 km per hour, and it takes 4 hours to row to a place and return back. The total time for the upstream travel as well as downstream travel, both are combined together, it is going to be 4 hours. How far is the place? So we are going to find the distance between the starting point and the ending point. So the speed of the boat is x kilometer per hour, flow of the stream is y kilometer per hour. For the upstream travel, the speed of the boat will be x minus y kilometer per hour. For downward stream, it will be x plus y kilometer per hour. So we write speed of the boat in still water. X kilometer per hour. Speed of the stream. Y kilometer per hour. And x is given to us. Still water, the speed is going to be 8 kilometer per hour. And speed of the stream is 2 kilometer per hour. Now, upstream speed of the boat is reduced. So x minus y, which is nothing but 8 minus 2, it is 6 kilometer per hour. Downstream, speed of the boat, it is going to be increased. So x plus y, that is equal to 8 plus 2, that is nothing but 10 kilometer per hour. Now the total time taken for the upstream travel as well as downstream travel is going to be 4 hours. And we don't know the value of the distance traveled. That's what we are going to find out. So we take distance between the places as d. So upstream travel time, distance divided by speed, that is nothing but d divided by 6. Downstream travel time, again it is d divided by speed, that is same distance, but the speed is going to be now 10. Now we find the total time. We take this as t1 and this as t2, and given total time travel for upward as well as downward is going to be 4 hours. So d divided by 6 plus d divided by 10 is equal to 4. We take LCM now. 10d plus 6d divided by 60 is equal to 4, which implies 16d is equal to 4 into 60. So d is equal to 4 into 60 divided by 16. We can cancel now easily. 4 times this 4 15 times. So it is 15 kilometer. So distance between two places is 15 kilometer. So we found the distance between the two places, which is equal to 15 kilometers. In this problem, the speed of a boat in still water is 12 km per hour and the speed of the stream is 2 km per hour. A person row to a place at a distance of 70 km and returns back to the starting point. Find the total time taken by him. So here we are going to find the total distance travel. Here we are going to find the total time taken for the upward travel and downward travel. Speed of the boat in still water. X, that is equal to 12 km per hour. Speed of the stream, that is nothing but y we are taking, which is given to us 2 km per hour. So this boat is going to travel at 12 km per hour and the flow of water is going to be 2 km per hour. and speed of the upstream travel, speed for the upstream travel, it will be 12 minus 2, that is going to be equal to 10. And for the downstream, it is 12 plus 2, 14. Speed of the boat upstream. Upstream rowing, so it is x equal to x minus y, that is equal to 12 minus 2, that is equal to 10. Now we are finding the speed of the boat for downstream. How to find the speed of the boat in the downstream? It is x plus y. 12 plus 2, that is equal to 14. And distance travelled. For upward as well as downward, it is going to be 70 kilometer. Downstream distance travelled also 70 kilometer. Now how to find time? We have the formula. Distance is nothing but time into speed. Now we are going to concentrate on time. So time is nothing but distance by speed. So total time will be time for upstream travel plus time for downstream travel. So time is given by the formula distance by speed. So distance traveled will be 70 divided by, for upstream speed is going to be 10. So 70 divided by 10 plus again 70 divided by 14. Because for the downstream the speed is going to be 14. So we try to simplify this expression. 70 by 10, it is 7. 70 by 14, we cancel this, 1 14s are 14, 5 14s are 70. So 5. So 7 plus 5, it is 12 hours. So the total time taken by him for upstream travel as well as downstream travel is going to be 12 hours. So total time taken by him is 12 hours. Hi students. A boat goes 30 km downstream and comes back to the starting point in 4 hours 30 minutes. If the speed of the boat in still water is 15 km per hour, find the speed of the stream. So the distance travelled by the boat downstream is 30 km, upstream also 30 km, and the total time taken for them is 4 hours 30 minutes. The speed of the boat in still water is given to be 15 km. We are supposed to find the speed of the stream. So we start. speed of the boat in still water. (15 km/h) given to us, and we usually take this as x. Speed of the stream, we take it as y km/h. Upstream speed of the boat, upstream, it is going to be x minus y, which is nothing but 15 minus y. Downstream, speed of the boat, which is nothing but x plus y, which is nothing but 15 plus y. So speed we found out with the given data, and the distance covered is going to be 30 km for both upstream as well as downstream. Now the total time taken for them for upward and downward, the time taken for them is going to be 4 hours 30 minutes. So we make use of this. Time is equal to distance by speed. Time for upstream plus time for downstream is given to be 4 hours 30 minutes. It is given in hours and minutes, so we try to convert this one. So we convert first of all 30 minutes to hour. So we divide by 60. 30 by 60, which is nothing but 1 by 2. So 30 minutes is nothing but 1 by 2 of an hour. Half an hour. Now, for 1 by 2 we are going to simplify. So this nothing but 2 4s are 8, 8 plus 1, 9. So it is 9 by 2. So we substitute here. Time for upstream travel 30 divided by, that is distance by speed, 30 divided by upstream. So 15 minus y plus downstream 30 divided by 15 plus y is equal to 9 by 2. We take LCM now. So it is 30 into 50 plus y plus 30 into 15 minus y divided by 15 minus y into 15 plus y, that is equal to 9 by 2. We simplify this expression. 30 into 15, 450 plus 30y, again 450 minus 30y divided by a minus b into a plus b. So it is 15 square minus y square, that is equal to 9 by 2. So plus 30y minus 35 cancel. So we get 900 by 15 minus y square is equal to 9 by 2, which implies we cross multiply the terms. 15 minus y square, 15 square minus y square is equal to 2 into 900 by 9. So we cancel this 100. So we get 225 minus y square is equal to 200. So minus y square is equal to 200 minus 225, which is nothing but minus 25. So we have the expression 200 minus 225, we subtract, so minus 25. So we get minus y square is equal to minus 25, which implies y is equal to plus or minus 5, and we take y is equal to plus 5, as y cannot take the value, negative value, as y cannot take the negative value. So speed of the stream is 5 kilometer per hour. Here we are having another problem. A boat takes 90 minutes less to travel 36 kilometer downstream than to travel the same distance upstream. Okay. So for downstream travel, the time is less. It is less by 90 minutes than the upstream travel. If the speed of the boat in still water is 10 km per hour, we are supposed to find the speed of the stream. Distance traveled is 36 km per 36 km. Speed of the boat in still water x kilometer, and it is given to us 10 km per hour. Speed of the stream we are supposed to find. We take that as y kilometer per hour, and here also it is going to be per hour. Okay. Now speed of the boat upstream is going to be x minus y, that is nothing but 10 minus y kilometer per hour. Speed of the boat downstream, for the downward motion, downstream motion, the speed of the boat will be increased. It will be x plus y, that is 10 plus y kilometer per hour. Now distance is already given to us, so we are supposed to calculate the time taken for the upstream travel and time taken for the downstream travel. Upstream travel will take more time because the speed is less, and time calculation formula used is time is given by distance divided by speed. So time is given by distance traveled divided by speed. So time for upward travel, upstream travel, minus time for downstream travel is given to be 90 minutes. We must convert this one to hour because all the units are in hour. It is not in minutes. So we divide 90 by 60. So 9 by 60 is nothing but 3 by 2 hour. So time taken for the upstream travel. Distance covered is 36 kilometer and the speed of the boat upstream is 10 minus y minus downstream. It is 36 by 10 plus y and it is 90 minutes. We rewritten that as 3 by 2. Now we are going to take LCM. LCM will be 10 minus y into 10 plus y. We simplify this expression. 36 into 10 plus y minus 36 into 10 minus y is equal to 3 by 2. So we simplify this expression. (360) plus 36y minus 360 plus 36y divided by 10 square minus y square is equal to 3 by 2. So here plus 360 and minus 360 cancelled. So we get 72y in the numerator divided by 100 minus y square is equal to 3 by 2. So we cross multiply. 72y into 2 divided by 3 is equal to 100 minus y square. So we cancel 3. This is 24. So 24 into 2, 48y is equal to 100 minus y square. We bring all the term to one side. So y square plus 48y minus 100 equal to 0. So we have to solve this quadratic equation. So how to solve the quadratic equation? We have to factorize. On multiplication we should get minus 100. On addition we should get 48. So the product is 100 and the difference. Why we are saying it is difference? Because we are having negative sign for the product. So we are supposed to find the difference. So the difference of the number should be 48 and the product should be 100. So we find 50 into 2. So plus 50 minus 2. So y minus 2 into y plus 50 equal to 0. So it is y equal to 2, as y is equal to minus 50 is not possible. Why it is not possible? The speed cannot be negative. Speed of the boat downstream is, speed of the boat, speed of the stream is (2 kilometer per hour). So if the boat takes 90 minutes less to travel 36 kilometer downstream and to travel the same distance upstream, if the speed of the boat in still water is 10 kilometer, then speed of the stream is 2 kilometer per hour.